Can one infinity be greater than another infinity? Well, to answer this, let's look at some examples. We are going to look at infinite sets. Counting numbers is an example of an infinite set. Counting numbers are the numbers that we count with. 1, 2, 3, 4, 5, 6, and infinitely onwards. Another set of infinite numbers are the integers. The integers include negative numbers such as -3, -2, -1, 0, and positive numbers like 1, 2, 3, 4, 5, 6, and infinitely onward in both directions. Okay, so this is where things start to get interesting. Are these infinities the same size? Well, all the countable numbers are part of the integer set. So, wouldn't integers be greater than the counting numbers? Well, actually, no. And here is why. These sets are actually equal. And to prove that they're equal, all we have to do is prove that we can pair all of the counting numbers with all of the integers. If the counting number is even, we are going to use the following formula. N represents the counting number. If we divide this number by 2 and subtract 1, it will result in 0 and all positive numbers. For example, 2 will result in 0, 4 will result in 1, 6 will result in 2, etc. If odd, we will use this formula. This is going to result in all the negative numbers. If you insert 1, you will get -1. If you insert 3, you will get -2. If you insert 5, you will get -3. With these two formulas, we just paired up all the counting numbers with all the integers, and therefore proved they are equal. So, are there actually infinities that are larger than others? Actually, yes. Here is an example. All the numbers in between 0 and 1 are greater than all the countable numbers. In between any two numbers, there's an infinite number of numbers. This means that no matter how we try to pair them up, we will always be missing numbers in between the ones that we've already listed. Let's start by listing a bunch of decimals. Now there's a simple way to make a new decimal with and be sure that it's not the same as any of the decimals before. As long as the new decimal has at least one digit different from all the decimals before, it's an entirely different decimal. So if we simply go in a diagonal line and make sure that that digit in the new decimal is different than the ones before, then it's an entirely new decimal. Now let's do another one. So now this is the next digit in the diagonal line. Since it's the 6th number, it's the 6th digit. Now let's make our new decimal. All of the digits up till the 7th digit are the same as our 6th decimal. However, since the 7th digit is different, then it is an entirely new decimal. We can do this infinitely and go on forever, and it's really interesting. And we've just proved that all the numbers between 0 and 1 are greater than all the countable numbers. The set of all real numbers between 0 and 1 is an uncountable infinity, whereas the countable numbers are a countable infinity. I'm fairly sure that any uncountable infinity is greater than any countable infinity. However, this has not been proven, at least as far as I know.